Okay, we saw in 7-4A, we were factoring quadratic trinomials that had a positive constant. Now we're going to go ahead and start looking at quadratic trinomials that have a negative constant. We're going to solve them the exact same way. It's just that all of a sudden we're going to have a negative. And we all know that in order to have a negative product, you have to have one positive and one negative factor. So now my factors have to be positive and negative. So as I look at this very first slide, if I were you, I would be very overwhelmed, but let's not. Let's just take it one step at a time. I start with my 4x squared plus 7x minus 2. All right, my A is 4. My C, negative 2, my constant. And my sum of my outer and my inner from the FOIL method, which we are calling B, is a positive 7. Now, if we use the textbook method, which we had already decided in 7-4A, that was pretty complicated, but it requires you to make these tables. You have to list all the factors of A, the factors of C. Then you have to do the outside and the inside products and add them together in order to get values for B. That takes a long time. This one is very simple. I gave you the answer right away and on the third try. But you could go on and on for a long time doing this. So, of course, what I would like to do is go straight to Daniel's method, which we introduced in 7-4A. So my equation, 4x squared, not equation, my expression, 4x squared plus 7x minus 2. I'm going to use Daniel's method again. I am going to take A times C. So 4 times negative 2 equals negative 8. I need to take factors of negative 8 that when added together equal B, 7. This part right here is the most important part about Daniel's method. You multiply A times C and you get a number. That value is the one you use to find the factors that add to B. So let's go back. I have 4x squared plus 7x minus 2. I bring down my ax squared, which is 4x squared. I bring down my constant, which is negative 2. What I am looking for is this 8x and this negative 1. Those were my two factors over here. I fill them in once I knew they were the factors. F1 and F2, I called them. Again, you can see that I have a common factor of this binomial. I pull out the 4x. So 4x goes into 4x squared x times. 4x goes into 8x twice. Here I'm going to pull out a negative 1. So I am going to have negative 1 on the outside, goes into negative 1x x times, goes into negative 2, positive 2 times. Now I have a duplicated binomial, which will become my second binomial. My first one, 4x minus 1. There's my first binomial, my second binomial. If I use the FOIL method, I will be able to get right back to where I started. So again, if you need to go back and watch 7-4A, then you should do that. Let's look at another example. Here I have a negative B and a negative C. Okay, we know that one has to be positive and one has to be negative factor in order to get this negative 15. So we know that. But we also now realize that the larger absolute value has to be negative when you do the two factors. Now I am showing you the tables like the textbook would show you. You can see this would be very time consuming. You can stop the video so that you can again see that I'm multiplying the outside factors, adding them to the product of the inside factors until I find a set that adds to that equals negative 7. Very time consuming. Let's jump to Daniel's method. In Daniel's method, he says take 2 times negative 15. 2 times negative 15 is negative 30. Find 2 factors of negative 30 that will equal b, negative 7. Now, all of a sudden, you should start to realize this isn't so hard. Okay, negative 10 and 3. Perfect. I plug negative 10 under F1, positive 3 under F2. I bring down my ax squared. I bring down my c from the original trinomial, and I have my 2 sets of binomials. Now, of course, you always have to clean things up. Let's pull out the common factors. I pulled out 2x, goes into 2x squared x times. 2x goes into negative 10x, negative 5 times. I pull out the 3, and look, I get the x minus 5 again. So I have a common binomial. I take the 2x plus 3, and here you have it. You have your 2 binomials that if you multiply them together, you will get back to your original question, 2x squared minus 7x minus 15. I encourage you to use FOIL right now and to make sure that you get back to the original problem. I do not show that as one of my examples. If I was in a classroom, I would. We'd have lots of time, but I'm trying to keep these videos under 15 minutes. Let's see what else we have. Practice. Perfect. So let's practice. We take 6x squared plus 7x minus 3. The main thing that you're going to want to do is do 6 times negative 3 is negative 18. I need factors of negative 18 that are going to equal a positive 7. In order to have a negative 18, I've got a positive and a negative factor. Well, the larger absolute value factor is going to have to be positive in order to get that positive 7. I'd like you to try it. I'm going to show it to you, but I'd like you to try it. Down here I have 4n squared minus n minus 3. The first thing I would do is put that invisible 1 in front of the n. So what I'm looking for is 4 times negative 3 is negative 12. I need factors of negative 12 that are going to give me, when added together, a negative 1. Hold the tape, try the problem, and let me go ahead to the answer. Okay, what I have here is 2x plus 3 times 3x minus 1. Or you could say 3x minus 1 times 2x plus 3. Remember that the commutative property of multiplication tells you that the order does not matter for multiplication. So it's okay to take the 2 binomials and reverse their order. 4n squared minus n minus 3, I get 4n plus 3 times n minus 1. Or again, I could change the order to n minus 1 times 4n plus 3. Take a good look at them. Make sure they match your answers. Let's try one. 3n squared plus 4n plus 1. I have a positive c, I have a positive b. 3 times 1 is 3. I need factors of 3 that add up to equal 4. This should seem a little bit easy for you. Pause the video, and I'm going to move on to the answer. Welcome back. And here where we have our answer. We started with 3n squared plus 4n plus 1. I came over here and I did 3 times 1 equals 3. Factors of 3 that equal 4, the b value, 3 and 1. I drop 3 and 1 in here. I bring down my a squared. I bring my constant down. Now I pull out common factors. Here I have 1n plus 1. Well, there's not, the common factor here is 1. What I'm trying to do is just get to make you realize that you need to put this invisible 1 on the outside of the parentheses so that when you build your second binomial, you have 3n plus 1. And then you have your duplicated binomial n plus 1. And this is your finished product. Here we have a negative a. When you have a negative a, we have a whole nother thing happening. Just when we thought it couldn't get worse, it just did. When the leading coefficient is negative, you can factor negative 1 from each term before using other factor methods, and this will create a positive a. So right from the beginning, I could pull negative 1 out to the side. And then I just need to factor the trinomial 2x squared plus 15x plus 7. So I took negative 1 out of each term, and I pulled it to the side. I'm not going to get rid of it. I just pulled it to the side. It's going to become my first term. I come here, and now I go ahead and I factor it. I end up with an x plus 7 and a 2x plus 1. But my negative 1 stays on the outside. So all I do is have to go back and factor this trinomial, this quadratic trinomial, the way we have been. I just need to remember to include the negative 1 before my parentheses. Let's look at Daniel's method. In Daniel's method, I started with negative 2x squared minus 15x minus 7. I took the negative 1 out and I gave myself a positive trinomial. 2 times 7 is 14. Factors of 14 that add to 15, the b value. I got a 14 and a 1. I plop in the 14 here. I put in the 1 here. I bring down my ax squared. I bring down my constant. Now, I have this negative 1. I'm not going to lose it. But I have 2x squared plus 14x, and I have common factors within it. So I pull the 2x out. Here, I pull out the invisible 1, and I leave that x plus 7. I end up with negative 1 times 2x plus 1 times x plus 7. I spoke very quickly. You really need to go back and take a look at this. In a classroom, I could spend an abundance of time on this, which I do. But this is a video, and I'm going to keep moving. Try them. I have 2 problems for you to try. I suggest you pause the screen so that you can try them. They both have negative b values, negative a values, negative c values. Let's see what we're going to do. Pause. Let's start again. You can see that I pulled the negative 1 out, and then I factored. What if I don't leave that negative 1 out? What if in some textbooks I notice that they don't have the negative 1 to the side? Okay, so what they did was they multiplied negative 1 times the first binomial. You don't do it again by the second binomial. Multiplication moves across. And I could have this, and both could be correct. However, a true factorization is going to pull that negative 1 out and leave it out. So I would recommend the first answer as a true factorization. Sadly, I saw in textbooks that they don't always do that. You know how you love math. They do what they want. Every time you never know what answer you're going to get. I'm going to show you how I got these answers though, okay? One last slide. If you can follow all this, you can see what I've done. In the first one, I did not pull out the negative 1 right away, but in the second one, I did. So in 4a, negative 6 times negative 12, a positive 72. I have my 2 negative factors. I get negative 17. I drop in negative 8. I drop in negative 9. I put them where I saw that I could have, common factors. In all honesty, whether I had put the 8 here or the 9 here, I still would have had common factors. It just would have looked a little different. But in the end, you get the same answer. We all know that math allows you to solve math problems 100 different ways. That's why your teacher always tells you you must show your work. I need to see how you did it. If Daniel had never showed his work, I wouldn't have Daniel's method. And you'd all be making tables and tables and tables of factors. Show your work. Find your own new method that maybe would work. For now, we're going to use Daniel's method, and I hope that you are able to go back, look at these. Of course, go back and just look at your permanent slides that are already on your drive if you're one of my students, so that you can go slowly and look at all of this. Thank you and good luck.